어, 아, 진짜 너무 좋아.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. I truly believe that responsive small launch will change the world.
Good afternoon, everyone, and welcome to the live stream for Virgin Orbit's Above the Clouds mission. We are live in our studio here in beautiful Long Beach, California, right down the road from our manufacturing headquarters. My name is Erica Wellnitz, and I'm the Senior Financial Analyst here at Virgin Orbit. And today, I'm joined by my two wonderful co-hosts, Paul and Spencer.
And good afternoon. We are so excited to be here with you today. My name is Paul Anderson. I am Lead Systems Engineer for Vox Space. Vox is Virgin Orbit's subsidiary focused on bringing Launcher One's responsive, flexible, dedicated launch services
말살가 많은
to the
거네.
U.S. national security space enterprise. We're so excited to go above the clouds with you today over the course of this live stream, and we have a lot of exciting content over the next few hours. Over to our third co-host, Spencer.
And my name is Spencer Stebbins. I'm an aerodynamicist here at Virgin Orbit. A lot of the work I do was actually modified the same system in order to actually carry our rocket as well. Beyond that modification, we also did some other simple modifications like removing unnecessary weight, such as the passenger seats that sit on the 747, as well as the bar that actually is on the second floor of the 747. With these two elements, the rocket and Cosmic Girl, we were able to design an air launch system that was unparalleled in mobility
아,
and provided
지금
a way to create missions with greater flexibility. With that being said, let's take a quick look at our launch timeline so you can know what to expect throughout the rest of today's mission.
어, 자, 저도 느끼게 되는데 확인해 보니까 발사가 지금 9분 전으로 바로 다시 돌아갔습니다. 이거 9분 전으로. 그래서 제가 이거 처음부터 결정하다가 일단은 진짜 아무걸 본 적이 없죠. 이 시간이 굉장히 힘들어요. 9분 전이니까 제
Above the
상태.
Clouds, to pay homage to Virgin Records, the company that started the Virgin brand. We went around the factory here in Long Beach and let some of our teammates listen to the song. Let's hear what a few of them had to say about it.
지금 보시면은 누가 이걸 보실까요?
So I know we're naming our rockets after
그 오른쪽 보면은
this is exciting
네,
because
지금 비행기는 이륙이 지금 57분 전에 지금 했는데 지금 발사는 지금 14분 전으로
I
들어갔어요.
haven't seen a turntable since I was a kid. So this takes me back a long
지금부터
way.
됩니다. 이런
Back in
재밌네요.
high school, we were spinning this at house parties and really enjoying the underground
네,
atmosphere.
이 시간에 보게 됩니다. 들어보기 아파가지고 좀.
Above the clouds, infinite skills create miracle. Yeah, that's talking my.
Gangstar, I'm a big fan. My favorite producer, that's DJ Premier. My favorite MC, Guru, rest in peace. My favorite Wu-Tang member, also feature track, Inspect the Deck.
This song is pretty dope. I like the music. The beat is pretty good. Upbeat, love it.
And I love hip hop. I grew up listening to Gangstar,
나중에 한번 제가 다시
Wu-Tang.
한번 정리를
I spent most of my
전체
time
상황을
on the beach and
얘기해
listening to
드릴게요.
stuff, so reminiscing, and I just don't think they make music like they used to. So
It's awesome. You know, not every
잠깐만,
day
또
that
이거.
a company does something cool that involves hip hop.
Good beat, interesting lyrics, a dance beat that made me move. And if something makes me move, then it's good. So, definitely a thumbs up.
I think my daughter would be very proud of me that
지금 그
I'm in it and I'm
회사
not like
회사 홍보하는 것 같아요.
you know,
아우.
I'm not a boomer, but she says, "Hey, boomer," you know, and they can stop calling me office grandpa in the office because now I'm hip.
Gangstar are loving it.
I like it. That's a great song to name our next rocket after. We're going to be successful just like the song was.
And I want to say it's an honor to pay homage to Gangstar in this next launch.
So let's keep playing on. Go Virgin.
During the flight to orbit, Launcher One will be transmitting a signal containing key mission information for Mission Control Center operators back in Mojave. So shown on the screen now are the locations of the ground antennas that we will use to capture this telemetry stream
이런 또
broadcast by the
이거 원래
Launcher One
발사
rocket on its way up
아
to
목이
orbit.
아프네.
Telemetry is on a radio
발사
frequency
이러네요.
RF signal containing critical information about Launcher One's subsystems, performance, and the environments that Launcher One and its payloads
나중에는
will be
뭐
experiencing during the
이렇게
various phases
전
of
일본
flight to orbit.
공수하고
And the ground station shown on this graphic here
발사를
will
한다는
receive
것도
that signal
얘기했습니다.
and send the data on that signal to our Mission Control Center for monitoring, processing, and to that
발사를 안 하고
rocket status
있었구나,
GUI
지금.
that Spencer has been
발사
showing us here on
기간이
this live stream.
처음에 언제 발사하는지 이거 확실히 정해진 거 아니에요, 그거요. 그래서 지금 11분 남았죠? 나중에는 한번 전체적인 과정을 다시 한번 볼 겁니다, 저도. 어우, 이거 무지 아프네요. 아, 그래서 미리 한번, 자, 여기 계신 분, 아무도 안 계시지만, 제가 밤새 종이를 거의 잡아버렸어요. 그래서 촬영 같이. 오늘 한 11개 같이 발사했거든요. 국방부 연관의 발사가 그, 8개. 나머지 3개가 이제 영국, 폴란드, 오스트리아 이렇게 해가지고 발사가 있는 상황인데요. 네, 지금 비행기 가는 상황이죠. 잠시만 기다려보세요. 자, 들어오신 분들에 대해서 다시 설명해 드리면은, 지금 8분, 지금 런처원 로켓이 발사되기 지금 8분 전입니다. 그리고 8분 전이고, 아, 어쨌든, 로켓 발사가 지금 하기 전이라는 거. 거의 지금, 비행기 뜬 거는, 비행기 뜬 거는 지금 1시간 5분 전인데, 비행기 이륙한 게요. 저기 지금 발사가 지금 되려고 하는 것은 8분 전이다. 노력이 됐어요. 그래서 지금, 꽤나 이제 복잡한 구조로 되어 있기 때문에, 기상 조건이 안 맞거나, 하여튼, 그래서 노력이 됐답니다. 그래서 좀 정리해봐야 되는데, 저도 지금 인제이라고 정신 하나도 없이 들고 있어요. 그래서 이 시간대에 발사하면 너무너무 힘들어요. 이게 잠을 잘 수도 없고, 앉을 수 없고 상황이라서. 여튼 간에, 발사하기 직전이라는 거. 그나마 뭐 다행이라고 다행이죠. 지금 연료하고 산화제 지금 들어가 있는데 100% 들어가 있다. 뭐 이렇게 보여준 것 같고요. 이 시간대는 뭐, 거의 뭐, 한국은 이제 거의 아침 시간이니까 정신없죠. 지금 비행기가 돌아가면서, 그리고 이제 올 11개 발사합니다. 11개. 진짜. 이게 소리가 끊기네, 이게. 잠깐만요. 다시 말씀드리면은, 발사되기 지금 4분 전이죠, 이제. 진짜 이렇게 끊기죠. 그럴 줄 알아요. 자, 이 시간대 높이 가서는 너무 높습니다. 아, 이런. 멈춰버렸어. 아, 못살 것 같은데. 시간이 할 수밖에 없습니다. 그렇지? 네, 지금 2분 남았습니다. 계속 몇 번 걸려가지고 죄송합니다.
Miguel, accelerate.
Copy, accelerating.
네, 이따 제가 다시 한번 끝나면은 어떻게 됐는지 한번 정리를 한번 다시 한번 보여드리겠습니다.
Base copies, rocket on entering power.
아이씨. 아, 이거 지금 카운트다운도 지금 2주씩 떨어지네, 이게. 시간 안 돼. 1분 30초 남았죠?
Import shield nominal. Rocket systems nominal. Over base LE2, aircraft S-band and Avis has confirmed to go.
Base
Oh,
copies, aircraft
well.
has been, AFS has confirmed go.
어쨌거나 이 발사는 너무나 힘듭니다. 어쨌거나. 왜냐면 태평양 상공에서 하는 발사이기 때문에 더 그래요. 열심히 선회를 하고 있죠. 아, 이러다가 또 발사 또 안 하고 못할 수도 있어요, 또. 이러다가 또 발사를 못할 수도 있습니다. 말 그대로 연기되거나 취소될 수도 있다는 거죠.
LRC alarm initiated.
네, 지금 26도 과연 될까요? 네, 이제 거의 시간 됐는데요. 6초, 4초. 자, 이제 카운트가 됐는데요. 과연 발사가 될까요? 네, 드럼 내리 아직도 좀 대기 상태네요.
Copy, Paul.
발사가 됐나요? 저 밑에 지금 로켓 해가지고 로켓 스피드하고 발사가 된 것 같은데요?
Launcher 1 is drop ready, as we can see. Now, unfortunately, we're not going to have the rocket cam for the drop, but we should be able to acquire that telemetry right afterwards.
다시 또 이게
Seeing Launcher 1 on her way.
뭐죠? 안 되는 것 같은데?
Looks like we made it above the clouds and onward to orbit.
Base copies, we're above the clouds.
Ah, it's a beauty up here.
Max Alpha flight complete.
발사가 됐네요. 예, 지금 1분, 아이고야. 지금 발사가 됐어요. 1분 전에. 예, 런처에 발사가 돼가지고 지금 카운터는 지금 이제 T 플러스로, D 플러스로 가고 있죠.
Max Q Alpha flight complete.
발사가 됐습니다. 예, 저기 발사. 예, 지금 옆에 카메라를 좀 보여주고 있는데.
View it here.
예, 버진오빗 발사가 됐어요. 전체적인 모습은 나중에 좀 봐야 될 것 같아요.
We are level up, and we have a pretty good view up here.
Base copies.
So as you all might have heard on MCC, we were able to drop successfully and separate from Cosmic Girl. We have already passed a number of milestones on our way here. Currently, you can see the rocket is at 3,000
지금
miles.
프레임이래 가지고 여기 보이는 게 지금 불꽃이에요. 지금 발사된 겁니다, 지금.
And so we're definitely cruising through. We already made through our supersonic regime.
발사가 됐습니다. 이렇게 말을 못하겠어요. 이거 너무 이게 다른 유형의 발사다 보니까 저도 이게 공부를 지금 이렇게 발사할 줄은. 지금 발사가 된 상태고 2분 넘어가고 있죠. S1, S2가 있는데 S1은 안에 지금 런처원에 지금 두 번에 지금 작은 로켓이 이제 있다고 생각되는데 S1이 지금 이제 점화돼가지고 지금 올라가고 있는 것 같다. 그리고 S1이 컷오프 되고 있다. 이렇게 생각하면 될 것 같은데요. 네, 지금 전혀 영상이 전혀 없죠. 없습니다.
Drawdown commanded.
저기 어느 쪽 카메라지?
No.3 shutdown confirmed.
예, 저기 스테이지 1이 지금 점화됐죠. 관제가 올라가고 있다. 성공하냐 1편은 봐야 될 건데.
And amazing views that we're seeing right now. The blue has gone to black, and that is the limb of the Earth in view. Launcher 1 is in space.
네, 지금 분리가 됐다 나오네요. 분리됐네 이미. 스테이지 분리. 언제 분리했어?
Fairing brake wires broken.
편이 떨어나갔네요. 편이 떨어나갔네요. 방금 전에. 그래도 이거 보네요. 페어링이 떨어나갔습니다.
So what you might have just seen on the video is we just had successful fairing separation from
네,
stage
페어링
2.
세퍼레이션 확인했고요.
Actually, you can perfectly see the satellite.
지금 나왔네요. 올라왔습니다.
Gorgeous view of our system in space.
Yeah, look at that. There's our
발사하는 과정은
payload
그래도
stack.
다행히
Again, to our
진단할 수
7
다행입니다.
customers, welcome to orbit. If we have more time in the schedule before the payload deployment, but Launcher 1 is in space. What a
네,
beautiful sight.
올라갔어요. 성공했네요.
And we're getting word now that we are having great connection with all of our ground stations.
저게 비행기 띄우는 시간 따로 있고 발사하는 과정이 따로 있어야 되다 보니까 저게 효용성이 얼마나 있냐 그게 항상 무리하게 됩니다. 이 버진오빗은 저거 발사 안 되는데 집어넣을게요. 어쨌든 발사는 됐습니다. 근데 참 이렇게 이런 발사를 봐야 되는 게 아직 낯설기는 합니다, 지금. 그리고 지금 페어링 세퍼레이션하고 두 번째 2단 엔진 컷오프가 됐나요? 아직 안 됐죠? 7개 지금 아까 나왔는데. 아, 이거 7개 피해 그런가? 이거 11개라고 있는 것 같은데. 헷갈리네요. 아, 지금 일단 분리는 했고요. 아, 그니까, 이게, 여기서 트윗에서 올린 거 보면은, 이게 어메이징 뷰 해가지고 나왔는데, 지금 나오긴 하네요, 지금 상태는. 이게 그렇게 재밌는 발사가 아니라는 거예요, 지금. 카메라, 어느 쪽인가요, 지금? 네, 지금 카메라하고 전체 보여주는 것은 그렇게 재밌는 발사가 안 보이는 거예요. 여기 오른쪽, 여기 보면은, 여기 지금 1단하고 2단하고 지금 같이 지금 연소가 되고 있다. 여기 나오죠? 가운데. 일단 전체적으로, 산화제랑 연료랑 같이 지금 소모가 되고 있으면서 지금 점화를 되고 있고, 페어링 부분 위에 이제 있고요. 뭐야. 뭐야, 또. 로코드가 지금 64km.
So listening into mission control, we
올라오긴
just heard that
한데,
we're over
어떤
halfway
상태지,
through
지금?
our stage 2 burn, as you can see on our GUI on the screen. Here we're looking at some of the information about our stage 2 rocket. On the left side, you can see the gimbaling of our nozzle itself and the thrust vector there, as well as the expenditure of some of our fuels, like the fuel and liquid oxygen on board our stage 2 rocket.
나중에 이제 영상을 보여줄 거예요. 영상을 보여줄 건데,
One minute to seeker.
진짜, 힘들네. 연료 산화제에서 다 쓰고 있는 상황이고, 두 번째 컷오프, 두 번째 번. 스테이지 2는 질소하고 헬륨을 쓰는군요, 이게.
AFSS mission rules satisfied.
30 seconds.
질소 산화제하고 헬륨 산화제 있거든요. 그래서 지금 뭐지? 캘리포니아 반도긴 한다. 네. 스페이스입니다. 올라가고 그런데 64km.
Newton 4 shutdown confirmed.
왜 고도가 떨어지지 같아? 올라가긴 하네. 지금 타겟이 보여주고
Coast
있네요.
started, barbecue roll started.
진짜 무겁다.
So we just heard from Mission Control that we just shut off Newton 4. So that was our SECO 1. And we've begun that maneuver that we mentioned earlier.
지금 두 번째
called barbecue
엔진
roll.
컷오프 됐다. 지금 보여주고 있고요.
And now launcher 1 is going to coast all the way out to orbit apogee. And there, Newton 4 will burn a second time. And after that, we will deploy our 7 customer payloads into that mission orbit.
아, 거의 지금 참신한 그 반응 세기라 해서 재밌을 것 같은데 재미가 더 없네. 재미가 없어. 재미가 더 없어 진짜. 새로운 방식이니까. 뭐가 그렇게
Telemetry is beginning to go intermittent on us, man.
고도가 그렇게 아주 엄청 올라갔다는 건 올라간 건 아니에요.
Copy that. Estimated LD on control. Go ahead. Looking for permission to release
네, 지금 완전히 연료 다 썼죠.
Don't we need to wait until we're over land? Do we need to wait till over land? Stand by. The answer is no. Our FA rep is shaking. Oh, okay. Then you're good to release. Copy that.
아, 어제 그 스페이스X 그 부서 상륙하는 사진이 너무 잘 나왔다.
And we have loss of signal at Baja.
저 분리가 됐나요? 지금 오늘 그 올라가는 그 인공위성 지금 보이고 있는데
Ground on control.
Copy you on control.
Are you good to get going with this?
Yep, can do.
Sounds good. I'm going to be handing over to LC2 here.
진짜 인정합니다. 저도 빨리 다시 자고 싶어요. 이거.
Control room, this is GNC.
Go ahead, GNC.
SECO 1 orbital allowance, apogee of 524 kilometers, perigee 194 kilometers, 45-degree inclination.
Could you repeat just one more time?
Apogee is 524 kilometers, perigee 194 kilometers, and inclination 45 degrees.
Copy all. Thank you, GNC.
Plane getting off comms for a few minutes.
Copy that plane.
새벽 4시까지는 봐주겠는데, 그 다음부터는 힘들겠어. 제 푸념의 시간이 돼버려 말았죠. 아우.
Well, how awesome is this? We have successful confirmation that Launcher 1 is
Yeah,
coasting
little
and
close.
barbecue rolling in her transfer orbit out to apogee, but the mission isn't over yet. So be sure to follow Virgin Orbit on social media for more mission updates to follow, including confirmation of payload deployment.
We want to thank everyone who tuned in for our Above the Clouds mission today. We also want to thank our customers for flying with us. And a special shout out to our live stream production crew, brand team, and my co-hosts, Paul and Spencer.
I want to also give a special shout out to all the engineers and technicians who I can hear on mission control right now cheering in the background. They have been working diligently and they've been working odd hours to make sure both Rocket and Cosmic Girl were ready to go today so that we were successful for our mission.
We've entered into commercial service and we are delivering on our commitments to our customers because here at Virgin Orbit, we release,
repeat.
Take care.
잘 끊었네요. 왜 그러지? 너무 좋았지. 지금 상당히 이럴 줄 알았어요. 버진오빗은 웹캐스트를 정리하고 패드도 제보를 온라인으로 업데이트 할 예정입니다. 임무의 다음 시상국기에는 아마 아프리카 공화국이 이제 통신을 받으니까 그때 볼 것이다 할 것이겠죠. 끝나면은 앞에서 다시 보여줄 거예요. 어제도 뭐 끝난 것 같습니다. 애매하게 끝나긴 했지만. 끝났습니다. 그래서 제 앞에부터 다시 보여줄 테니까요. 다시 보시기 바랍니다.
Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0.
I truly believe that responsive small launch will change the world.
Good afternoon, everyone, and welcome to the live stream for Virgin Orbit's Above the Clouds mission. We are live in our studio here in beautiful Long Beach, California, right down the road from our manufacturing headquarters. My name is Erica Wellnitz, and I'm the Senior Financial Analyst here at Virgin Orbit. And today, I'm joined by my two wonderful co-hosts, Paul and Spencer.
And good afternoon. We are so excited to be here with you today. My name is Paul Anderson. I am Lead Systems Engineer for Vox Space. Vox is Virgin Orbit's subsidiary focused on bringing Launcher One's responsive, flexible, dedicated launch services to the U.S. national security space enterprise. We're so excited to go above the clouds with you today over the course of this live stream, and we have a lot of exciting content over the next few hours. Over to our third co-host, Spencer.
And my name is Spencer Stebbins. I'm an aerodynamicist here at Virgin Orbit. A lot of the work I do was actually modified the same system in order to actually carry our rocket as well. Beyond that modification, we also did some other simple modifications like removing unnecessary weight, such as the passenger seats that sit on the 747, as well as the bar that actually is on the second floor of the 747. With these two elements, the rocket and Cosmic Girl, we were able to design an air launch system that was unparalleled in mobility and provided a way to create missions with greater flexibility. With that being said, let's take a quick look at our launch timeline so you can know what to expect throughout the rest of today's mission.
Expected warnings. Clearing place after warning. Clearing S2 lock stiff warning. SMA, this is CE on control room. We are pulling for good to take off.
Stand by for SMA.
Copy.
Let's take a look at some views from our launch site today up in Mojave Air and Spaceport in Mojave, California. Mojave Air and Spaceport originally opened as the Mojave Airport in 1935 and was granted its spaceport license through the Federal Aviation Administration in 2004, becoming the first private airport in the U.S. with a commercial spaceflight license.
So what you're actually seeing through some of these shots, especially this one, is a large wind turbine farm in the background. Fun fact about Mojave, it's actually home to the third largest onshore wind energy project in the world.
And if you're based in the LA area and plan on going skiing or snowboarding anytime soon up at Mammoth Mountain, you will drive right past the Mojave Air and Spaceport on the 14 freeway. And if you're lucky, you may even get a chance to see Cosmic Girl.
Yeah, and let me add this. Mojave has a rich history in aerospace flight testing and space industry development, but since it's located in the Mojave Desert, the only thing you'll find more dangerous than the rocket engine testing are the creatures that live there. The black widow spider, the tarantula hawk wasp, and the Mojave green rattlesnake, very poisonous, all call Mojave home, so watch your step.
I've actually seen a black widow in person, and those things are so tiny. It's impressive that they can pack such a horrible bite to them.
Absolutely.
Well, one more fun fact for you guys. This was actually where the VSS Unity of our sister company, Virgin Galactic, reached suborbital spaceflight for the very first time back in 2018.
Virgin Orbit and Virgin Galactic are separate but sister companies with a shared founder, Sir Richard Branson. Virgin Galactic is opening space for everyone by enabling affordable suborbital human spaceflight so that anyone can become an astronaut. I know I'd love to fly to space one day. But Virgin Orbit is opening space for everyone by enabling affordable, anytime, anywhere orbital access for small satellites that bring positive change to all of us back here on Earth.
So to help everyone at home differentiate between Virgin Orbit and Virgin Galactic, let's take a quick look at our launch simulation that we've put together for you.
I'm in charge of getting everything ready for launch day. So everything from making sure the plane is ready, the ground support equipment and the rocket are all ready to go, as well as the people on console and all of our procedures and operations are ready to support a successful launch.
The launch engineers on launch day, we're at L-0 day. It's our big game day. We first go out before rocket loading and we do our pre-flight checkouts just to make sure everything is good to go before we load cryogenics onto the vehicle.
For last launch, I came in after fuel load, and I sit on console to monitor the system during engine bleed and TVC bleed.
I'm really focused on the risk of our program, so any kind of technical or program risk that we have, and then if something comes up at the last minute, really working with those teams to disposition that and address it as quickly as possible.
It's amazing to be part of the launch operation team because it's kind of a testimony of like how hard the entire company works together, from manufacturing to integration to all the engineering support.
As soon as you release the rocket, I think it's honestly is when it hits you, because during the time of terminal count and all the way leading up to it, you're pretty laser focused. Really, it's not until after the release of the rocket that you really take all those emotions in.
There was a lot of intimidation walking into an incredibly successful company that was really ambitious with their goals, and to see that we had so much representation on our first operational launch was really, really special to be a part of, because I think it's the next step forward as the industry kind of recognizes the value of diversity in their workplace, but also being now at 50% representation, it's really great to not be the only woman in the room.
I think as a company, there's definitely room to grow and room for improvement, and get the company at more of that 50-50 sort of level, but it is amazing to see so many females doing so many amazing things.
Alrighty, everyone, it looks like Cosmic Girl is moving towards the runway. She should be wheels up in no time. I'm pretty pumped. What about you guys?
Oh, I'm so excited. Oh, you can see such a beautiful shot of her right there as she's moving down the tarmac. Such a beautiful day in Mojave right now, especially you can see the size of Cosmic Girl on the rocket underneath wing. It's such an impressive sight.
Yeah, now Launcher 1 is 70 feet long, and when you're up next to Launcher 1, fully integrated in the factory, she looks to be a fairly large rocket, but under the wing there of a Boeing 747-400, this massive two-story commercial jetliner, Launcher 1 looks small indeed. But what an exciting moment here as we get ready for this distinguishing feature of air launch, the takeoff of the carrier aircraft from the runway.
And actually, that's one of my favorite things about working at Virgin Orbit. I work above the manufacturing shop floor, and we have like a nice window overseeing the whole flooring. So you can see pieces of the rocket as it comes together, and so you can see the size of it, and it's absolutely breathtaking. But when you see the whole thing put together, it's even more so amazing. I can't wait to see this baby launch today.
Yeah, and what's so inspiring, I think, about this, we have a lot of scientists, engineers, and future explorers who are watching this live stream right now. And, just a word to them, what you're seeing on the screen right now is it's not taught in schools. You're not going to find a textbook that shows you how to do this. This right here, integrated plane, rocket, and satellites, all as a single system, that was born through ingenuity, creativity, and the imagination of a world-class team, I think one of the best in the world.
Engine 2 rotation. Engine 3 rotation.
Clearing the AFSS fault logic, discussion with flight software. It was a blip, there's nothing in the error logs, and it was not seen on the plane.
Copy.
LD terminal, plane and control room, please meet me on plane.
Well, as you can see, Cosmic Girl and Launcher One are still on the ground. We're taking this time to go through some final checks of subsystem performance and verification of system health. So stay tuned, stand by. We'll provide an updated takeoff time as soon as we have it.
And as you can see now, Cosmic Girl is taxiing towards the runway. Her engines are all warmed up and ready to go, so we should be wheels up in no time.
Yeah, again, very, very exciting. You can see the 70-foot-long Launcher One rocket safely nestled under the left wing there of Cosmic Girl, the Boeing 747 carrier aircraft. We're just moments away from one of the early stages of air launch, which is the takeoff of the aircraft from the runway. to begin our transit time of about an hour over to our Pacific Ocean drop point, at which point we will release Launcher 1 to begin powered flight to orbit. And there you have a successful takeoff of Cosmic Girl and Launcher 1 from the runway at the Mojave Air and Spaceport in Mojave, California. Looks like Cosmic Girl is on her way to going above the clouds.
I know. That was an absolutely gorgeous view of Cosmic Girl as she was taking off with the Eastern Sierras in the background. Well, a fun fact about the design for the rocket, one of the things we had to consider from an aerodynamic standpoint was making sure that the rocket didn't have too large of tail fins so they wouldn't strike the tarmac as Cosmic Girl was taking off. So we had to do a little design right there to get it just right.
And as a reminder, Cosmic Girl will be flying out to the Pacific Ocean to the drop point, which is about 50 miles south of the Channel Islands. And now joining us is a very special guest, the founder of the Virgin Group, the man, the myth, the legend himself, Sir Richard Branson.
Hi, nice to talk to you.
Nice seeing you today, Richard. So you were in Mojave for our last launch, Tubular Bells Part 1. How are you feeling after just watching Cosmic Girl take off?
Obviously, just like all of you, excited, always slightly nervous at this stage. You can never be sure in these early flights whether every mission is going to be successful. But you know, just at the edge of my seat, like you and the rest of them, and it's incredible what the whole team have accomplished. I can't remember whether this is our third flight or fourth flight, but anyway, it's always incredible to be watching, and a great privilege.
Now, Sir Richard, the beauty of flexible small launch is that we can service a diverse array of customers on the same flight. On this one, we have U.S. government, U.S. commercial, and international customer payloads. What do you find most exciting about that?
Oh, look, I think that you know, for people who question space exploration, they don't realize just how much it offers to mankind back here on Earth. I mean, one of our satellites that is going up today will be monitoring agriculture and crops around the world and so on. And you know, it is that wonderful diversity of different organizations and different companies that have got brilliant ideas to try to use space to better things back here on Earth. And you know, I think we've got something like 20 other customers waiting in the wings after this to put their projects up, and I'm sure there'll be many more after that.
Absolutely.
So let's talk about the future of Virgin Orbit, actually. I know we have a number of launches coming up. Which one are you most excited about?
I mean, I think that I was just looking at the 747 and having a little bit of a trip down memory lane. And you know, this plane was I think the second plane into Virgin Atlantic's fleet, something like 38 years ago. You know, I wasn't sure that Virgin Atlantic would survive more than a year or two, and I don't think anybody were in those days. We were taking on, you know, British Airways with 300 planes, and we had a couple of planes. I certainly was not sure that, or never dreamt that one day it would be taking off from Mojave with a giant rocket on its side, and putting, you know, satellites up into different places in space. And the tremendous thing about using a 747 is we can put them into, you know, any orbit from anywhere in the world. So it's definitely a pinch me moment. I mean, you know, this goes right back to when I one day saw one of our 747s taking off with 3 engines on one side and 2 engines on the other, and we just suddenly thought, well, if you can get 3 engines on one side of a 747, maybe we could put a rocket on it. The reason for 3 engines on one side and 2 engines on the other was, you know, if there's a technical problem in Alaska, you have to send one of your other 747s to bring a spare engine. The only way you're going to get it there is to put it on the wing. As to the future, I mean, I'm obviously excited about every single rocket launch and all the different things that all the satellites inside those rockets can do. I mean, there are so many urgent things that need doing back here on Earth. You know, whether it's, you know, monitoring the rainforests, maybe places like Norway who are doing deals with places like Brazil to ask them, you know, to not to cut down the rainforests, and then rewarding countries for for not cutting down rainforest. The only way you can properly check on it is really via satellite. I mean, you can do a certain amount on the ground, but to completely verify it on a month-by-month basis, you need to do it from the air. So it's projects like that. I mean, in the Virgin Islands, right here, we have illegal, fishing boats coming through. Again, it needs satellites to be able to alert the authorities that trawlers are coming through with massive nets and long lines and pillaging the seas that belong to the British Virgin Islanders, and that's the kind of role that Virgin Orbit can play, and Virgin Orbit is unique in the world. I mean, the fact that we can actually, there's only, I think, a couple of handfuls of countries that have the capability of sending satellites to space from their own countries. And now all 180 countries can use Virgin Orbit. They just need to ring us up. We can send a 747 and operate out of their own country and launch satellites for the first time. The UK is one good example. I mean, later this year, we should be launching from Cornwall. The UK's never put up its own satellites. Now, I think this year there will be two flights from the UK, putting satellites up from the UK, and there are many other countries that have expressed similar interests.
And one last question for you, Richard. So as you may know, we have many international viewers watching from around the globe, but in particular, we have a small number here in California, namely our Virgin Orbit employees, that are primarily watching from home with their families due to the coronavirus pandemic. Is there anything in particular that you'd like to say to them?
Well, first of all, to say, thank you for all you've achieved. Obviously, we hope for a successful flight. And, if it's not successful, we'll be, back putting up another rocket, I'm sure, knowing the lot of you within a month or two. But I'm sure it's going to be a success. To wish everybody well. I mean, our family and friends all got COVID over Christmas, and fortunately we were vaccinated and boosted, and therefore none of us got it badly. I mean, my wife, who's a bit older than me, hardly knew she'd had it. So if you can get yourself vaccinated, get yourself boosted, get yourself protected, you can then I think ride this particular Omicron variant, and be around to watch many more flights, but basically just say thanks very much. I mean, you've achieved something extraordinary, and I know that you'll have lots more extraordinary things to achieve in the years to come.
Well, thank you very, very much for joining us, Richard, and we hope to see you back shortly.
Thank you very much. Cheers. Good luck in the next hour.
Thank you.
Cheers.
Joining us live in the studio here in Long Beach, California is a special guest, Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, or STP for short. Colonel, thank you so much for being with us today and for taking the time away from your mission team to join us on air.
Absolutely. It's great to be back, Paul. I appreciate it. Great day today. Another opportunity for us to put additional capability into space, to continue to push the envelope and actually take care of business so we can get the warfighter the tools that they need.
Excellent. So tell us more about DoD Space Test Program, who you are and what you accomplish.
Absolutely. So the Space Test Program has been around for a long time, over 54 years. And the job of our job is to demonstrate technologies, upcoming technologies, to accelerate development of war-winning capabilities for the joint warfighter. Our job is we do this by taking those technologies, do the mission design, the vehicle procurement, we do the integration, launch, and operations, and then take and analyze those capabilities, those technologies, and see which ones are ready to go to the next level. And the next level means for operations and to support of the activities and the missions that the Space Force needs to do. And this is critical because the Space Test Program is helping the Space Force, the Department of Defense, Space Systems Command to go after the threat and make sure that we stay relevant and the equipment is ready to do the mission and support our brothers in arms.
Excellent. Now, this mission is part of the Rapid Agile Launch Initiative, or the Raleigh project. Could you tell us a little bit more about the goals of that project specifically?
Yeah, absolutely. So the Raleigh, which is the Rapid Agile Launch Initiative, is one of those, it was a congressional initiative, and it was meant to help a venture class launch, small launch providers with using commercial practices to come and be able to support the mission of the Department of Defense. And the idea of those activities to be able to leverage new technologies, new processes, new equipment, and see if we can actually leverage and have a more resilient capability associated with the launch enterprise. And why is that important? Well, it's important because we need that to do our space mission. We, STP, in conjunction with our brothers on the launch enterprise side, as part of Space Systems Command, are trying to push that technology forward, have a more resilient capability, so when we need it, it's there for us to deliver the capabilities that our leadership needs in space.
So there are 4 STP-sponsored payloads on the Above the Clouds manifest. How are those payloads selected by your organization?
So all the space technologies that STP flies are going through what we call the Space Experiments Review Board. And it's a DoD-wide activity where all the different agencies and services bring their upcoming technologies and the demonstrations that they need, and then they get rack and stacked. And then once that gets approved by headquarters at Space Force, then we take those and then we execute to those. So once STP gets that list, then we work through our process, like I talked about, mission design or space acquisition or spacecraft acquisition. And then we go through that process and then we manifest, and that's how we got into this specific mission.
Excellent. So Cosmic Girl just took off. She and Launcher One are on their way to the drop point. It's going to get very exciting here soon. You know, in your view, what capability does this bring to the Space Force, the Department of Defense, and your mission partners?
Yeah, I think when it comes to mind is flexibility. We always looking for flexibility because we need to be able to act and be able to provide the technology not only that works, but also in a timely manner. And the concept that Vox has, where deploying from an aircraft, allowing that flexibility, because now you're not specifically attached to a specific ground point and the challenges that can come with that. So I think we're excited about seeing where this technology goes and the opportunity of that. This is our second launch with Vox with that VP Alpha, and that went very well. We're looking forward to another successful mission, another opportunity to actually showcase not only the technologies that we have on board this specific capability or the specific mission, but also to showcase the ability of Vox to do their mission.
Well, thank you so much, Colonel, for coming on the program here today. That is Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, demonstrating emerging technologies in space to accelerate the development of space capabilities for the warfighter. Stay tuned for more exciting content. We're getting closer and closer to Launcher One's drop time. Stick with us. We'll be back soon.
LD's Radiohead. I can report we have good signal, good tracking on all 3 ground stations right now.
Copy. No good tracking. I like it.
All base copying. We're level 30,000 feet. We remain in cloud.
Base copy is 30,000 feet, still in clouds.
Cosmic Curl orbit base.
Go ahead.
Yeah, Cosmic Curl orbit base. On the S-turn maneuver, what we're really looking for is 30 to 45 degrees of heading change in 2 different directions. It's your standard INS realignment kind of maneuver.
We haven't been briefed on an S-turn maneuver.
Say that again.
Yeah, this is to address the GNC Converge LCC. We're currently not passing. I believe the IMU is not currently aligned, so we're looking to do that maneuver that we're describing.
Okay, that's copied. And can you repeat the maneuver?
Yeah, Cosmic Curl orbit base. What we're looking for is 2 different heading changes, about 30 degrees to 45 degrees each direction. You probably won't be able to do that until you get into the Altrav airspace.
Yeah, that's copied. We'll try and do that as early as we can to get an early call on it.
Copy all, thanks.
Above the Clouds is our name for the STP-27VP Bravo mission conducted under the Space Test Program's Rapid Agile Launch Initiative, or RALI. The RALI project was initiated in response to congressional guidance to procure prototype commercial small launch services capable of taking research and development payloads into low Earth orbit. Above the Clouds will launch 4 STP-sponsored payloads to demonstrate flexible, responsive, non-traditional launch capability for the U.S. Department of Defense. Let's take a closer look at these payloads. The Pathfinder for Autonomous Navigation, or PAN experiment, demonstrates a low-cost, adaptable autonomous rendezvous and docking solution using 2 3U CubeSats designed with modular subsystem functionality. Technology Education Satellite 13, or TESS-13, is a 3U CubeSat experiment sponsored by the NASA Ames Research Center, exploring novel capabilities including nanosatellite class machine learning, exobraking for rapid deorbit, and advanced communications. The Global Star Evaluation and Risk Reduction Satellite, or GEARS-3, is a 3U CubeSat sponsored by the Air Force Research Laboratory to explore how a prototype patch placed on the exterior can provide details on spacecraft health via commercial satellite network connectivity. And in addition to these 4 STP-sponsored payloads, the Above the Clouds manifest also includes 3 commercial rideshare satellites. Polish new space company Sat Revolution is flying their Stork 3 and SteamSat 2 satellites. Stork 3 joins the Stork 4 and Stork 5 MARTA satellites placed in orbit by Launcher 1 on our 2021 Tubular Bells Part 1 mission as part of Sat Revolution's Earth observation capabilities with a focus on customers in the agricultural sector. SteamSat 2 is a technology demonstration for Steamjet Space System UK's innovative water-field thrusters for in-space propulsion. And finally, as a late call-up addition to the Above the Clouds manifest, from final approval to full integration in less than 24 hours, is Spire Global's Adler-1 satellite. This 3U CubeSat mission is the first privately organized satellite of Austria, tackling the challenge of micro-space debris, small particles with high velocities that can pose a serious danger to orbiting satellites. A partnership between the Austrian Space Forum, Findus Venture, and Spire, Adler-1 focuses on detecting nearby objects too small to detect from the ground. This nanosatellite detects space debris via a radar and using a piezoacoustic sensor that vibrates on impact, literally a microphone in space. Findus Venture is financing the mission, and the Austrian Space Forum is a space research organization with more than 250 volunteers from 20 countries. To these 7 payload teams, welcome aboard Launcher 1, and we wish you 100% mission success as you go above the clouds to use your technologies for the benefit of all of us back here on Earth. Now, let's hear more about the TESS-13 satellite in particular and the amazing team behind this satellite. Go ahead and roll the video.
This is Techosat number 13, and this is our second flight on Virgin orbit, which we're very happy to be part of. And this particular mission is a 3U nanosatellite, and it's full of rather interesting and innovative experiments. We're very cognizant of orbital debris, and so by having a drag device that is simple and reliable, it means that we can bring our nanosatellites down and dispose of them a lot faster, not having them as a potential debris for other satellites or human vehicles to run into.
And I'm really happy to be part of the exobrake team, so I was involved in the design and the building phase of the subsystem. So we are a small team, and I really want to acknowledge one of our colleagues, and I call him like the hero of Techosat. He's really quiet, really discreet. His name is Alejandro Salas, and he's our lead ops engineer.
This will be the first of a series of flights that will begin to expand on machine learning in space.
Today, we got a chance to go in the clean room, do the final voltage testing, and then with the help of the Virgin Orbit team, we were able to integrate the satellite into the flight dispenser. Today was a really smooth process that my team and I hope Virgin Orbit team also enjoyed.
We command and control satellites through email, which is very unique. and we pioneered that some years ago, and it works to a great extent. We got injected into a perfect orbit, and that was a year ago, and then 9 months later, the satellite still sends lots of valuable data, so it's up there. The timing will be such that we'll have 2 satellites in orbit at the same time, thanks to Virgin Orbit.
I think TechEdsat it's really important from a NASA standpoint, but also for the entire space community. TechEdsat Group gives an opportunity to entry-level engineer to really be part of a space mission, and I think you change the entire space ecosystem because you get a chance to fly your own payload. When I was doing my master's degree at San Jose State University, I was already part of the TechEdsat team, and that's where I started working on the exobrake. So over the past years, I was able to work on 3 exobrakes. To be the first female customer, first of all, I was surprised because I was greeted here by 3 or 4 women, right, at Virgin Orbit. So I felt like home. They were all the personnel here. It's really, really nice, and they make sure we have everything to complete the integration.
We're just happy to be here again, and we look forward to 2 more flights in the next calendar year.
Thank you. Thank you to my team. Thank you to Virgin Orbit, because I also think that it's a great collaborative effort. And during this challenging year, we were able to work together, put a satellite together, and today integrate. So we are all, cheering for Virgin Orbit right now and hoping for the best.
So for those watching a live stream today, what you've most likely seen in the background is a number of graphical user interfaces, or GUIs. Now, these GUIs are composed of some of the parameters our launch team across Virgin Orbit are monitoring to make sure they keep track of the health and status of both Cosmic Girl and the rocket. Let's go ahead and take a look at one of those GUIs. These GUIs will show captive carry, stage 1 ascent, and stage 2 ascent. The current GUI that we have on the screen right now is for captive carry. To give you a little breakdown of what you're seeing on this GUI, let's first focus on the primary section of this one. Here you see an animation or a comic version of the rocket itself with a couple of our tanks overlaid on top. Those tanks represent our fuel and liquid oxygen tanks. Here you can see the fill level. Obviously, since we're still in captive carry, they haven't decreased yet. Up below the rocket, you can see some of the other components that comprise our rocket, like No.3, stage 1, inner stage, stage 2, and the payload. Here, we're tracking some of the key parameters like temperature and pressure. Across the bottom of this GUI, you can see some other information regarding both Cosmic Girl and the rocket pertaining to bus voltage, the speed and altitude of Cosmic Girl, which you can see is flying at 420 miles per hour at an altitude of 31,000 feet, as well as our pallet and pylon, which is our separation system for the rocket. So by all means, stay tuned throughout the rest of today's mission and take a look at these GUIs as they update, as they will provide plenty of information on the relevant section of our flight segment.
Let's go ahead and take a look at a highlight reel of Cosmic Girl and Launcher 1 taking off from the Mojave Air and Spaceport earlier today. That occurred at about 1:38 p.m. Pacific time.
And there we go. Our flying launch pad, Cosmic Girl, is up and away.
So once again, what we just saw was Cosmic Girl taking off. That actually happened at 1:38 PST, so that happened a little bit earlier today. But I'd also like to take this time to give a shout out to our flight crew. We have 2 pilots flying, Eric Bibbert and Matthew Stanley Standard, as well as 2 launch engineers. So thank you all for your hard work in making sure our rocket gets to the drop point.
LDS Radiohead, just a report that we're seeing expected losses at the point we are in the flight. All ground stations are operating as expected at this point.
Copy. Ground stations acting as expected.
Yeah.
So as Cosmic Girl carries our rocket out to a drop point, I wanted to give you a quick rundown of the flight profile you'll see our rocket complete today. To help visualize the flight path of the rocket, we have put together a little graphic for you. Once again, to start this segment of our mission, you will hear the pilots yell, "Release, release, release," when we're prepared to drop the rocket. 3 seconds after drop, we will ignite our propellant settling thrusters, followed shortly by our main engine start, which will pitch our rocket up and take us through the stage 1 flight phase. Through the next 150 seconds, our rocket will go from subsonic to hypersonic speeds as we climb up in altitude until we're about 5G in acceleration. At this point, the main engine, or No.3, will throttle down until all of the propellant has been expended, and we will transition to main engine cutoff, or MECO. Post-MECO, we'll go into a short coast until it is safe for stage 1 to separate away from the rest of the vehicle. Post-stage 1 separation, the rocket's second stage engine, or No.4, will begin its first run phase. At this point, we will have reached a huge milestone for our mission and will have made it to space. This will also mark a point where it will be safe to do fairing separation and set up our system for payload deployment. Around 500 seconds after the start of this portion of flight, we will have reached our transfer orbit and the second engine will cut off and end this first run phase. Next, we will see the vehicle enter into a maneuver we call the barbecue roll in order to ensure proper thermal balance across the vehicle. From here, we'll fly for about 30 to 45 minutes until we reach the apogee of our transfer orbit. Once we reach the desired point, we'll reorient the second stage for a quick second run phase of the No.4. This point will be very exciting as we have reached the final desired orbit and we will be ready to deploy the payloads for all of our eager customers. As we're flying and progressing through our mission, we'll definitely try to call out all of these milestones.
Now, Spencer, you are an aerodynamics engineer by training, and I know you love NASCAR, and you love all things fast. So, I want you to kind of geek out for a little bit here. So, tell us more about just how fast is Launcher One going to be flying, and, for an air launch system, what are some of the unique challenges with the early stages of that flight?
Oh, definitely. You're giving me a chance to be an aero nerd. So basically, from an aerodynamic standpoint, we break this up into 4 segments of flight, really. The first segment of flight is a separation away from Cosmic Girl, and we want to ensure that we have this correct because we want to make sure our pilots and the launch engineers flying Cosmic Girl today are safe. So we actually did work with NASA Ames and NASA Armstrong to make sure that we had safe separation down and ready to go. From here, we actually go into as I mentioned, 3 or 5 seconds after drop, we ignite our thrusters and we go into the subsonic flight regime. This is around Mach 0.6. Here, we see some challenges like flow separation and vortices along the length of our rocket. From here, we travel from subsonic to supersonic speeds, where we then have to begin to worry about shock propagation along the length of our vehicle and making sure that we can control it through this phase. After this, we go into hypersonic speeds, where we have to take in consideration thermal effects as well as other flow dynamic effects as well.
Now, Spencer, I heard you mention a barbecue roll. Is anyone else hungry, or did I just miss lunch?
Ooh, what's your favorite? Texas barbecue or Carolina barbecue?
I've never had Carolina barbecue, so I'm going to go with Texas for now. But anyways, getting back to it, the barbecue roll. So it sounds like a very technical aeronautical terminology there. What is it, and why do we do it?
Right, so it's simply a slow spin about the roll axis. So Launcher One will orient itself and slowly spin for what we call passive thermal control. So with respect to the position of the sun vector, we want to make sure that components on that second stage and our payloads don't get too hot or too cold, and so we slowly rotate, just like a good barbecue.
Man, that does make me hungry. Now I'm definitely going to have to go look on a food delivery app and see what the closest best barbecue is around here.
We'll be right back. For our mission name for today's launch, we thought it'd be a wonderful opportunity to celebrate the innovators we work with in the Virgin Group history, which, of course, all started with music at Virgin Records. Above the Clouds is a single by the artist duo Gangstar on their hit album Moment of Truth, which was released by Virgin Records in collaboration with New Tribe Records in 1998. We named this mission Above the Clouds to pay homage to Virgin Records, the company that started the Virgin brand. We went around the factory here in Long Beach and let some of our teammates listen to the song. Let's hear what a few of them had to say about it.
So I know we're naming our rockets after albums that were released on Virgin Records, but this is exciting because he even talks about going into space on this song too, so.
Well, first of all, I haven't seen a turntable since I was a kid, so this takes me back a long way.
Back in high school, we were spinning this at house parties and really enjoying the underground atmosphere that Gangstar provided.
Above the clouds, infinite skills create miracles. Yeah, that's talking to my head.
Gangstar, I'm a big fan. My favorite producer, that's DJ Premier. My favorite MC, Guru, rest in peace. My favorite Wu-Tang member, also featured on the track, Inspect the Deck.
This song is pretty dope. I like the music. The beat is pretty good. Upbeat, love it.
And I love hip-hop. I grew up listening to Gangstar, Wu-Tang. I spent most of my time just on the beach and listening to this stuff, so reminiscing, and I just don't think they make music like they used to, so.
It's awesome. You know, it's not every day that a company does something cool that involves hip-hop.
Good beat, interesting lyrics, a dance beat, so it made me move. And if something makes me move, then it's good. So, definitely a thumbs up.
I think my daughter would be very proud of me that I'm in it and I'm not like, I'm not a boomer, but she says, "Hey, boomer," and they can stop calling me office grandpa in the office because now I'm hip.
Gangstar are loving it.
I like it. That's a great song to name our next rocket after. We're going to be successful just like the song was.
And I just want to say it's an honor to pay homage to Gangstar in this next launch.
So let's keep playing on. Go Virgin.
During the flight to orbit, Launcher One will be transmitting a signal containing key mission information for Mission Control Center operators back in Mojave. So shown on the screen now are the locations of the ground antennas that we will use to capture this telemetry stream broadcast by the Launcher One rocket on its way up to orbit. Telemetry is on a radio frequency or RF signal containing critical information about Launcher One's subsystems, performance, and the environments that Launcher One and its payloads will be experiencing during the various phases of flight to orbit. And the ground station shown on this graphic here will receive that signal and send the data on that signal to our Mission Control Center for monitoring, processing, and to that rocket status GUI that Spencer has been showing us here on this live stream.
go. Accelerating.
Copy, accelerating.
Over base, LE2 confirmed rocket is on internal hours.
Base copies, rocket on internal power.
Good morning, smooth shell start.
For base, LE1 and 4 chill is initiated.
Copy, and 4 chill initiated.
N4 chill nominal. Rocket systems nominal.
Over base, LE2 aircraft S-band and AFS has confirmed to go.
Base copies, aircraft S-band and AFS has confirmed go.
LRC arm initiated.
Sorry, good morning. Vehicles under operating mode.
Copy, drop ready. Copy, pull.
Ignore warning.
Release.
Launcher 1 is drop ready, as we can see. Now, unfortunately, we're not going to have the rocket cam for the drop, but we should be able to acquire that telemetry right afterwards and begin seeing Launcher 1 on her way.
Looks like we made it above the clouds and onward to orbit.
Base copies, we're above the clouds.
It's a beauty up here.
Max Alpha flight complete.
Return stage 1 burn nominal.
Max Q Alpha flight complete. Control room, we have switched back to the Long Beach dish for telemetry on S-band.
View it here.
LE2, LE1, can you repeat last?
Stage 1.
We are level up, and we have a pretty good view up here.
Base copies.
So as you all might have heard on MCC, we were able to drop successfully and separate from Cosmic Girl. We have already passed a number of milestones on our way here. Currently, you can see the rocket is at 3,000 miles per hour. That's around Mach 4, 5. And so we're definitely cruising through. We already made through our supersonic regime.
Drawdown commanded.
The Gen.3 shutdown confirmed.
Stay step, brake wires broken.
And amazing views that we're seeing right now. The blue has gone to black, and that is the limb of the Earth in view. Launcher 1 is in space.
Fairing brake wires broken.
So what you might have just seen on the video is we just had successful fairing separation from stage 2. And our, actually, you can perfectly see the satellites right now. And that's an absolutely gorgeous view of our system in space.
Yeah, look at that. There's our integrated payload stack. Again, to our 7 customers, welcome to orbit. You know, if we have more time in the schedule before the payload deployment, but Launcher 1 is in space. What a beautiful sight.
And we're getting word now that we are having great connection with all of our ground stations.
Stage 2 PU nominal, halfway through burn.
So listening into mission control, we just heard that we're over halfway through our stage 2 burn, as you can see on our GUI on the screen. Here we're looking at some of the information about our stage 2 rocket. On the left side, you can see the gimbaling of our nozzle itself and the thrust vector there, as well as the expenditure of some of our fuels, like the fuel and liquid oxygen on board our stage 2 rocket.
1 minute to SECO.
AFSS mission rule satisfied.
30 seconds to SECO.
Newton 4 shutdown confirmed.
Okay. Coast started, barbecue roll started.
So we just heard from Mission Control that we just shut off Newton 4, so that was our SECO 1, and we've begun that maneuver that we mentioned earlier called barbecue roll.
And now launcher 1 is going to coast all the way out to orbit apogee, and there Newton 4 will burn a second time, and after that we will deploy our 7 customer payloads into that mission orbit.
Telemetry is beginning to go intermittent on S-band.
Copy that. Estimated LD on control. Go ahead.
Looking for permission to release the airspace in the LTRAV.
Don't we need to wait until we're over land? Do we need to wait till over land?
Stand by. The answer is no. Our FA rep is shaking.
Oh, okay. Then you're good to release.
Copy that.
And we have loss of signal at Baja.
ground on control.
Copy, you on control?
Are you good to get going with this?
Yep, can do.
Sounds good. I'm going to be handing over to LC2 here.
Control room, this is GNC.
Go ahead, GNC.
SECO 1, orbital allowance, apogee of 524 kilometers, perigee 194 kilometers, 45-degree inclination.
Could you repeat just one more time?
Apogee is 524 kilometers, perigee 194 kilometers, and inclination 45 degrees.
Copy all. Thank you, GNC.
Plane getting off comms for a few minutes.
Copy that plane.
Well, how awesome is this? We have successful confirmation that Launcher 1 is coasting and barbecue rolling in her transfer orbit out to apogee, but the mission isn't over yet. So be sure to follow Virgin Orbit on social media for more mission updates to follow, including confirmation of payload deployment.
We want to thank everyone who tuned in for our Above the Clouds mission today. We also want to thank our customers for flying with us. And a special shout out to our live stream production crew, brand team, and my co-hosts, Paul and Spencer.
I want to also give a special shout out to all the engineers and technicians who I can hear on mission control right now cheering in the background. They have been working diligently and they've been working odd hours to make sure both Rocket and Cosmic Girl were ready to go today so that we were successful for our mission.
We've entered into commercial service and we are delivering on our commitments to our customers. Because here at Virgin Orbit, we release,
repeat.
Take care.
RCP chamber pressure looks good.
Traveling up.
Water towers, fly! Tango Delta nominal.
Flight outside speed off. Bring in speed off.
Yikes. You bet. Concur. We don't need any more of these.
Hello and Happy New Year, everybody. Welcome to the first NSF Live of 2022. We're going to recap 2021. A lot of exciting stuff happened, and then talk about what we can expect in 2022. I am Stephen Marr. I'm one of the photographers here at NASA Spaceflight, and I am being joined today by Assistant Managing Editor Chris Gebhardt. How you doing, Chris?
I am doing quite well, and I'm sure a lot of people know why I'm here today.
And also one of our writers and also a voice you'll hear on a lot of these weekly Starship recaps. We have Ian Atkinson. How you doing, Ian?
Doing great, Stephen. Glad to be here. Very exciting year, and very exciting year to look forward to as well.
Yeah, we're going to get into predictions and what we expect to see fly this coming year. But we're going to start off with, I think, possibly the most important mission of the year, or perhaps some would argue the last 25 years. Oh, by the way, before we get into it, I just want to remind everybody, if you have any questions, put them in chat at NASA Spaceflight, included in the comments somewhere, and we will be able to see that and try to get to as many questions as we can. But yeah, let's talk about the most important mission this year, arguably. That would be James Webb Space Telescope. Chris, do you have any insight? Did you happen to see any news about this thing, this weird golden shaped thing?
I mean, I slept through it. No, no. I mean, this was incredible for so many different reasons, and you can see the offending plume. We're going to get to this. You can see the little offending plume that ruined the remote camera shot of this. But no, NASA Spaceflight was one of the very few media organizations in the world, all told about 20, that got access for this mission. And that was spread out across the United States, Canada, and the European Union. So very, very incredible to have the type of access that we did. And you can see the mixture of both the official live NASA feed that we had of the liftoff, as well as the video that I was shooting from the balcony of the Jupiter Control Center, and that's me.
There you are.
One of the very few moments we have ever shown a face on an NSF live stream of a liftoff. But we thought that was very important to do, just given where we were and how we were able to be there. And of course, that is a real scale mock-up of the Ariane 5 behind me in that image, and I am basically standing exactly where we shot the launch from and where I witnessed the liftoff from, which is about 12 kilometers away from the launch pad on the Jupiter Control Center. A terrace. So basically, at liftoff, when you see everyone on Arianespace webcasts run out onto the balconies from just behind the control center, I was one balcony up above them. So they all came running out below me, and they got to hear me scream, "Oh my God," when it lifted off. And it was much louder than that at liftoff, as the stream can attest.
I thought it was crazy, and it's probably normal, but I was noticing that the people inside that were kind of in the, I don't know, you call them bleachers that are around like the control room, they didn't run out until like a minute and a half to go. I was worried that they wouldn't all get outside in time, because they all got to funnel through the doors.
So thankfully there are many doors, like a concert stadium, to funnel you in. But yeah, the view, and we'll get to it at some point here in the video that we've got of the live stream. It's a very different view, and that's one of the things that going to different launch sites and experiencing the different terrains that the vehicles launch from is really part of the experience. So, in Florida, we're used and Baikonur, right? And Wallops, we're used to this very flat terrain where you can see pad after pad after pad after pad, right? At Vandenberg, we're used to, well, the pad's over there if the fog cooperates, but part of the part of the mystique, right, of the Guyana Space Center is that it launches from the Amazon rainforest, and we are firmly in the Amazon rainforest for this, and it will remind you of that every day with how much it rains.
And wasn't there a warning of leopards or?
Yeah.
Was it leopards?
They're reintroducing like jaguars. They're reintroducing jaguars,
right.
into the local population there, and one had been spotted just outside of the pad perimeter called the Round Road. For the Ariane 5 and Vega complex there when we were there. So wildlife preserve, just like we always talk about Kennedy being. But the reason they don't run outside any earlier than that is because you can only barely see like the very tippity top of the payload fairing of the Ariane 5.
Oh, okay.
And the top of the Lightning towers. So you can't really see the vehicle when it's on the pad there because it literally rises out of the jungle. As it ascends. So, I mean, it was incredible to be there for it. And of course, I was on my little phone watching the just shy of live images come back of payload fairing separation and the separation of the Webb telescope itself.
Yeah, that was a huge surprise. First, we got the CG version of it. And then all of a sudden they bring up actual views. It was like, I don't know, 5 or 10 seconds after actual, or I'm not sure exactly, but it was and here they are now.
And they had people reviewing that in the control room, making the decision, on the fly, was everything okay to show? And then they ended up going with it. And man, I think we all around the world had that little moment of, oh my gosh, it's waving goodbye when the solar panel popped out and everything. That was really unexpected. But, I'm sure there are a lot of questions, and we've got other things to show, another video and assets to show here and to talk about with the trip to French Guiana and everything and launch of James Webb. But before we just moved on, I wanted to say it was a huge thank you to Arianespace, who really was the one who put all of this together for the media and everything. It was an absolute incredible journey to work with them, and hopefully not the last time we do, given some more things that they've got coming up here. But really, my thanks to them for putting on a wonderful program for us and always having something for us to do, even with delays.
Oh, really?
Which we knew, you're going to encounter delays, so they always had things for us in the event that it had slipped further than the 25th.
Wow.
There would have been a jungle hike one day. Probably we would have gotten out to the Soyuz pad one day as well. Vega was a little tricky because it's partly there and it's solid rocket, so like it's a bit like more constrained. In that regard. But one of the launch delays actually allowed us to go to the Ariane 6 facilities, which we'll talk about coming up. But this was one that got me. When they said, oh yeah, and then you get to go see it before it rolls out. Like, I didn't think they meant, I mean, like, I'm literally 30 feet from that. Like,
It's a very, this is a wide angle. And if you know anything about wide angle, it makes distances look further actually. And you're much closer than it seems. Yeah. That is awesome.
Yeah, I mean, they brought us right up to it.
I mean, we don't ever get that close here at the Cape. Not that close.
No. Not without having to sign a lot of paperwork. No, so I mean, like, it was sort of, each day was structured sort of around what the vehicle was doing, where we were in the count, and when it was safe to go different places. So, because of how it worked, the day that we got there was the day that they ended up delaying from the 24th to the 25th. So we had this awkward extra L-3 day in there because they were simply moving the rollout and everything one day at a time. Because that's part of their sequencing, is to really only try to have the Ariane 5 out there for 2 days on the pad before your opening liftoff attempt.
Okay.
So, they were moving that, and that got us to see the Ariane 6 facilities, and then the next day was rollout. And man, when I said rollout in the jungle in my tweet, I really meant it, because like you have this shot right here which was basically the only moment it wasn't a torrential tropical downpour. But yeah, so basically it involved standing out there in a raincoat with the camera also having a raincoat on it, but also holding an umbrella so that the lens would not get wet.
Water, yeah.
As I tried to film the Ariane 5 going between the bushes in the gaps in the jungle and everything as she went out to the launch pad. So yeah, it's definitely you definitely get the full experience of being down there. If you stay outside for more than 15 minutes, I would say you're gonna get a rain shower.
Oh man! And how about the mosquitoes? I have to ask.
So the one thing that they absolutely warn you about, both before leaving the U.S. to go there and when you arrive, is bug spray. And mosquito repellent with very specific, like very specific, make sure it has this in it. And so as a result, the mosquitoes weren't too bad. But man, I will tell you this, a born and raised Florida boy, and that humidity gave me a run for my money.
Really?
Woo-hoo-hoo. Yeah. Yeah. I mean, Stephen, how during a Florida summer, there's nothing quite like moving into the air conditioning.
Oh, yeah.
But you don't normally have an audible, like, oh, reaction to doing so, which is what it was like for me down there. But, they also had a really nice... They also had a really nice Christmas Eve dinner for us because there were all of us who were there, who'd given up our holidays to be there, including the higher ups at Arianespace and NASA, like Thomas Zurbuchen and Stefan Israel, and all the, program managers and program scientists for Webb and the media members. It was all just a nice little, traditional, what we were told was basically a traditional French Christmas Eve dinner in French Guiana. Yes.
I mean, I feel like we need to get into spaceflight stuff, but I'm so interested about this. Like what's the traditional meal? Like, what do they have? Turkey, ham? What was it?
It's duck.
Oh, duck. Okay,
Duck.
cool.
Yes.
All right. Well, look, we can't tarry here too long because I know that chat wants to probably hear us talk about actual space things.
Well, that too, and I'm sure they've got questions about this themselves. So
they do, and I have one chambered, but give us sort of a rundown of where do we stand right now with James Webb on its way to Lagrange Point 2.
Yeah, so you can see the sort of live update right here for the distance of where it currently is. In terms of its deployment sequence, the update that we got just shortly before we came on air is that the additional tensioning that they were talking about that was initially yesterday, but they delayed it to today to give the team some time off, is now going to be tomorrow. At the earliest, they're really taking a lot of time here to get to understand exactly how the observatory is behaving as it goes through the deployment sequence. And a very important part of the deployment sequence is that each one of those things, each one of those moments can be paused. Right. So it's not like you do one thing and now you've got 15 minutes and then the next thing is going to automatically trigger like you would have in, say, a rocket's automated countdown sequence. Right, where stopping it means bringing the whole shebang to a close, and that's not the case with Webb. Right, we can pause, especially at these very key points, and sort of do what they're saying and let the telescope talk to them. They can get a sense for how it's behaving as it's cooling down, verify that it's behaving as they thought it would during the pre-launch and Earth-based deployment sequences that they took the Sun Shield through. One of the very good things is they practiced all of this, and they got to practice the whole deployment sequence of the Sun Shield on the ground. So the Sun Shield deployment is not one of those, oh gosh, they weren't able to test it before we lifted off things. So.
Was there anything off the top of your head?
Yes, the cryocooler.
Okay.
The very critical cryocooler. They could test each of the two components, but because one of the components is on the deployable boom and the other is on the spacecraft bus, so to speak, they were not able to test that completely. But the Sun Shield, they were. So, they're stopping, they're pausing, they're taking some more time. Ultimately, I think we can all agree, if it takes them 54 days and every single deployment thing works, fantastic. It took you
that's
54
great, yeah.
days. I'm not counting. You got
There's
it
no
all
rush.
deployed.
There's no
Exactly.
Take your
rush at all.
time.
Yeah.
Take your time.
Exactly. And you can sort of see them doing this. And another very important thing, we talked about the complexity of Webb's deployment a lot before it lifted off. It's also worth noting that this is also the first time we've done something like this, where we have deployed a telescope in this fashion. Forget the complexity of deploying it. It's the first time we've deployed a telescope like this, where it had to do all of these incredible folds to get into the payload fairing. So don't expect it to take 30 days. Expect it to take longer. But things do seem to be going very well. But of course, it is, worth mentioning that the sun shield is where the vast majority, like 87% of the single point failures reside. So this is the moment to really hold your breath. So this is the moment you would really want to see them taking a moment.
Right, and so we've got those mid boom arms extended, right? And so it has, in fact, I think the tweet that NASA put out was shine bright like a diamond. So yeah, it looks like that. It's not quite like it doesn't have tension yet, but it does have that diamond shape now, and that's like a big milestone, right?
It is. It really is. Because it's not just deploying it and getting it tensioned. It's then all the layers that have to start popping up individually for it, because the sun shield is the thing that not only helps keep the optics clear of scattered light. That's one of the things that the sun shield does. But its primary purpose is to passively cool the array down to between 30 and 50 degrees Kelvin, so that the cryo cooler can then take over and cool it down to 6 Kelvin.
Right.
And 0 Kelvin is absolute zero. So we're talking very, very cold is where we're headed. So yeah, this is one of those critical moments of getting the tension on them, because that's a huge thing that's needed for the next step and for the overall functionality of the array.
All right, let's hit a question here. I've got one. I think I've got a couple that relate to JWST. Tony says, if JWST is a full success and went 100%, do you think LAVOR, I'm not sure if I'm pronouncing that right, would be possibly funded? Out of the 4 observatories, which would you like funded? Love you all.
Ian, you want to go first?
Yeah, and this actually came to my mind when you were talking about the deployment of James Webb. So, like you said, nothing like this has been done before, but a lot of the proposed telescopes, notably LAVOIR, build on the technology of James Webb. LAVOIR, much like James Webb, in either of its 2 configurations, would have a folding mirror. So James Webb needs to demonstrate that this is possible to get LAVOIR funded. Now, we did see the decadal survey, which is basically a big congregation of astronomers, astrophysicists, scientists, basically getting together to say, what do we want to do this next decade? What do we want to fund and get started and launch? And they believe that NASA's next step after the Roman telescope would be to build a about 6-meter UV optical infrared telescope. And LAVOIR is a 9 to 15 meter UV optic infrared telescope. So it seems like LAVOIR or a LAVOIR derivative may be the next major space telescope. But again, that was a very arbitrary number. They said around 6 meter mirror diameter. That could be larger, could be smaller. That could be not even funded in general. So we're gonna have to watch over the next few years, see what NASA invests and see what NASA chooses. And from there, we can start to determine what is after James Webb.
Yeah, I mean, I think to the second part of your question, which one would I want to see funding? Well, all, and I say that with my astrophysicist and astrophysics heart on my sleeve there. All of them. LAVOIR would definitely be huge in that particular range, in that particular wavelength, but. I think one of the main stopping points for LAVOIR and for the types of telescopes that we have been talking about for a long time has been the sheer size, like you were saying there, Ian. The diameter of the LAVOIR mirror being between 9 and 12 meters in diameter. Well, even with the big shiny thing under development down in Texas, it would still have to fold up to fit inside Starship. And holy moly, Starship's massive. You've all seen it. So we're still talking about, like, even though the size of our potential launch vehicles for these things, even though they are getting larger in diameter and in larger in terms of the mass that they can take to low Earth orbit or beyond with refueling, we're still in this weird phase where you still need the telescopes in some ways to be bigger, to observe in the detail that we need them to be able to see, in the wavelengths and how far back they're able to see. Just like we just saw with Webb having to fold up, 340 some odd times just to fit inside the Ariane 5 payload fairing, and that payload fairing is huge, compared to the other vehicles that we have on the market at 5 meters in diameter and 16 meters in length. So, I think that's a huge element to what comes next. Now, if Starship does prove itself and prove itself to be a thing that can have the finesse as well to handle these really intensive NASA science missions and flagship science missions like LUVAR would be, I think we'd be there, in having a vehicle capable of lifting these things, and having that, as well as having, the price tag, the proposed price tag of a Starship, would be huge for launching something like this. Considering that, the LUVAR mirror is just eyeballing it about 4 times the size of the James Webb mirror, which was itself about 4 times the size of the Hubble mirror. So you can see how we're scaling here as we go out into the future.
All right. Well, let me see. We had Cape Town Knights over here asking Chris G directly. Chris G, what were your feelings when you saw the rocket that close? I mean, it has to be many, many years in the making to get to that spot, and there you were.
Yeah. Well, even when I was down there, as I said earlier, I didn't think I would be that close to Ariane 5. Both when she was still in the assembly, the final assembly building, and when she was out at the launch pad. The photos I showed were not as close as we got to her on the launch pad. We actually got closer. They very conveniently did not tell us that, so we did not have cameras at the ready when we drove by. But no, we did get closer. It was incredible. Like everything, the vehicles all sound very different. The launch pads sound very different. One thing I wasn't expecting at the Ariane 5 pad was what very much sounded like gunfire at first. Very loud, percussive pops, which I at first assumed to be like an animal system, like keep the animals away, right? Because the French Legion and the French military are there patrolling the forest, patrolling the perimeters prior to the liftoff, just like our military and security patrol, the Cape and Vandenberg and things like that. So I thought it was something like that, and then they said, no, that's how we burn off the hydrogen. When the liquid hydrogen is burning off in the holding tanks and everything there, they percussively, vaporize it as part of their system for how they pacify it after it turns to gas. So that's what we were hearing was basically the hydrogen burn-off system for the Ariane 5. So that was pretty cool.
Yeah, I didn't know that was
something
a
that
thing.
you would only have gotten being that close to the pad and being that close to the vehicle.
Let's see. Keith Tay wanted to know, does JWST use TDRS or Deep Space Network or other?
It uses the ground, actually. So it uses a series of ground tracking stations. So if you were watching the launch, and I don't know, maybe, Michael, we can find this part of the liftoff sequence where Ariane 5 is tracking across the Atlantic, you can see the series of different tracking stations. Nadal, Ascension are in the Atlantic. And then you have Malindi off the coast of Kenya in the Indian Ocean. And you can see the various tracking stations that she's communicating with on the ground. And if you think back, and I'll only mention this now since the launch was a success for James Webb, if you think back a few missions, a few years ago, back to 2017, I believe it was, yeah, you can see the ground tracking stations there in the center in the third image from the left there, as Ariane is tracking across the Atlantic there, right to the right of the weird mascot thing that has just appeared on the screen again, which I think we commented on during the broadcast as well. But those are the ground tracking stations that she communicates with during ascent. And if you think back to 2017, when they accidentally put in a 6-degree orbital inclination instead of a 3-degree orbital inclination, and Ariane wandered off into the wrong inclination,
Right.
and we lost communication with her because the ground tracking stations were not aimed for a 6-degree inclination. So she just went out of range of the ground tracking stations, but kept going and kept firing and kept doing everything. And then eventually when the satellites came back around, that's when they called home. And we were like, well, we're here. We're just not in the orbit we thought we would be in. And that's why we lost communication with the vehicle, because it doesn't communicate upward to TGIS like the U.S. rocket, like some U.S. rockets do.
Right. All right, and Nick, keep them coming, y'all. Make sure you remember to hit that at NASA Spaceflight, and we'll try to get your question answered here. Nick wanting to know, how long will it take until we get pictures from JWST? I think that's the question everybody wants to know.
Yes, it is. Yeah, so a great question to follow up the where are we now? It will be a while. It will be at least until the middle of this year, July, August-ish, if everything in the unfold process and the commissioning phase, because remember, it's not just the planned 30-ish day commissioning phase, or an unfolding phase, which will be a little longer now because we know they're taking a bit of extra time here. But it's also the commissioning phase, and it will take the cryo cooler, 5 months to cool this thing down so that the MIRI primary optic sensor that sees in the infrared will be able to see and get those first images, and you have to calibrate it. So it'll be probably July or August before we would get those first light images released by NASA, if everything goes to plan. Of course, if the commissioning takes a bit longer, if the deployment takes a bit longer, but we get there in the end, could be longer. But this is where the very accurate insertion of the Ariane 5 comes in really handy, because it gave them a lot of extra propellant to utilize for an actual operational mission.
Yeah.
And that's very much worth mentioning before we move on, because as much as we could just talk about Webb the entire day, Webb was not the only thing that happened in 2021, and Ian needs to talk at some point on this broadcast.
Right. Well, another very exciting thing that happened, and actually, it was my first time being on an NSF stream, was when Perseverance landed, of course, with Ingenuity on board. So how is that mission going?
Yeah, so Perseverance is going great. We saw it touch down in February. It touched down in the Jezera crater, which is an ancient river delta. So back when Mars had water billions of years ago, this area that Perseverance landed in was a river delta, basically where a river ended and moved into a large lake. They think that this area, out of anywhere on Mars, may have a high chance of having life if Mars ever had life. So the main point of the Perseverance mission is to find signs of ancient life and better understand the history of Mars. But Perseverance was not a single spacecraft. It actually brought along a little passenger, Ingenuity, which is a little drone. It's about the size like a cereal box or so, like a small suitcase. And Ingenuity is a little small drone with 2 propellers on top, and it was to demonstrate and gather data on what it's like to fly on another world. As of earlier this year, there had never been a flight of a winged or propeller vehicle off of Earth, but that changed when Ingenuity took off. As of now, it has completed over 15 flights. And it's just keep chugging along. It was originally supposed to just do 5 flights, but NASA loved it so much and it's brought back so much useful data. It's actually part of the science mission now. And they're using it to determine areas that is tough or would take a while for Perseverance to go to and figure out, oh, is this area of any scientific use, or is this actually safe to drive this way? Which is a major benefit. It increases the safety and the science return of the rover mission.
And I want to highlight one specific thing that you just said, because that's sort of the abstract, and it's already done that, because if you remember back when Perseverance went to do its first sample collection as part of the sample return portion of its mission, and they looked in the tube after they collected the sample, and they're like, "There's nothing here. What happened to it?" Like, and they realized they needed to go elsewhere. It was aerial images taken from Ingenuity that aimed them at the new location where they were then actually able to just move the rover over there. So Ingenuity really proven itself already.
Yeah, exactly. And the little thing just keeps going, and there's no sign that it's going to be stopping anytime soon. So
Yeah, did you?
very good.
Sorry, I had a weird glitch going on over here. But did you already say how far it's flown?
We have not yet, but it
It's
has
like,
flown.
yeah,
It's
go
like
ahead.
3.6 kilometers, I believe, so far. It's flown.
So impressive. And I know like before they actually started testing out Ingenuity, it was a lot of, this is just a demonstration test, and don't expect too much. But what it turned out doing is actually assisting with the primary mission, right? Like it's actually done a little bit of scouting already, right?
Yeah, absolutely. And that's its main purpose now, is to be a scout for Perseverance and to figure out, hey, this area over here looks neat. Let's check it out from the air and see what it's like. Let's go there with about a minute of travel time instead of days or weeks or months of travel time. Or saying, this area looks neat. We think we can go this way, but we're a little concerned. They can see it from the air and realize this is a dangerous obstacle, or this way over here looks much safer and much faster. And they've already had a situation where they determined a path, and they took Ingenuity up, looked around a little bit, and said, okay, that looks a little dangerous. We're going to take this easier path around that. And it's going to dramatically increase the scientific return and the safety and longevity of Perseverance, because I'm going to end my tangent here, but we saw the Spirit rover, which was landed in, I believe it was like 2004 or so. It got stuck in the sand, and it was unable to keep moving, and eventually it died because of the angle the solar panels were at and dust collection. So even though Perseverance is powered by plutonium, if it got stuck, that would suck. So just being able to make it safer, determine safer and faster paths, great benefits overall.
Yeah.
And the one thing I'll add in there, huge benefits because this has worked. The more and more flights they can get out of this rotorcraft flying around Mars, the more data they have for the much larger, like Curiosity-sized helicopter mobile flying thing called Dragonfly that they're going to send to Titan, the moon of Saturn, here at the end of the decade, which basically is a Perseverance-style machine, but instead of roving around Titan, it will have it will have the quadcopters and everything, and it will fly itself from science location to science location. And this is our reaction to Tango Delta Nominal 11 months ago when she touched down.
Yeah.
The wait for it.
And I'd like gotten excited a little too early, because we had done this a few years ago with, well, almost 10 years, I guess 9 years ago now, with Curiosity. So, the first time I ever heard Tango Delta Nominal was with the Curiosity stream. And so then whenever I heard that this time, I was ready to jump up and down, but everybody else was kind of reserved. And then finally they said touchdown confirmed, because I guess there was one other thing they had to check, but it was so intense and exciting. I think that's the thing that I love James Webb Space Telescope, but I think that was the thing that really got me going this year.
There was a lot, to be fair.
Yeah, this year, 2021 has been a big year for scientific exploration. And to bounce off of that, not only did we see Perseverance, we saw 2 other Mars missions arrive at Mars successfully. We saw the Al-Amal probe from the UAE, the first time they've ever sent a probe to Mars. We also saw the Chinese Tianwen-1 mission, which is a combined orbiter and lander and rover mission. Very successful overall, which is unheard of to have a first attempt at a Mars landing be successful. We can see a picture there of the rover and the lander.
Not to mention that epic flex that it did by dropping the camera and then reversing to take a selfie of itself with its landing platform. Yeah.
Yeah, this mission is all about deployable cameras. The rover's deployed cameras. The orbiter has deployed cameras. We saw a few days ago, and the orbiter, the Tianwen-1 orbiter, deployed a camera to look at itself looking at Mars. And it's just crazy to see that. Like, look at this. That looks like a render. Like that.
Yeah.
I know.
Yeah, there's the picture there. It's unbelievable.
Yeah, this is something you just don't get because, well, they don't typically deploy a camera just to look at at itself.
Yeah.
And you know, like the beauty of this is like we keep being surprised at these selfies that the mission keeps sending back when maybe we shouldn't have been, because like the first thing it did after leaving Earth orbit was to pop out that first CubeSat and take a photograph of itself that they could then transmit to the world to say it's real. And of course, a lot of this is China proving to the world that they're actually doing what they said they're going to do. But Ian, what you said, I mean, unprecedented to go for the trifecta on your first attempt to begin with.
Yep.
And even more jaw-droppingly awesome that they succeeded across the board on all three of them on their very first attempt. So that now makes India, the UAE, and China all succeeding at Mars on their very first attempts. And that's really impressive when you think that, you can't just say, oh, it's because the technology has improved, because the European Space Agency lost the Schiaparelli lander just a few years ago trying to land on Mars. No one would say that they're a technological newbie at this. Russia has very sadly yet to really succeed at at Mars endeavors, so it's not just technological advancement. There is still a lot of everything has to go right. So, major congratulations again. I know we said it earlier in the year, but yeah. Ooh.
Yeah. And when's the last time we've seen pictures from the little rover there? I don't remember seeing any anytime recently.
It's been a couple months.
Yeah.
Yeah, I think so, but we haven't heard any news on anything going good or anything going bad. So, and China is not the most publicly transparent space agency in terms of what they're doing, what they plan on doing. It's a lot of just like, hey, we are doing this in 10 minutes, or hey, we just did this 3 weeks ago.
Yeah.
So business as usual, it seems.
It might just be sort of we've shown everybody that we did it, and now they're just doing science.
Yeah.
I'm sure we'll hear about any major discoveries.
Yep. And also,
and to be fair, you don't see pictures from Perseverance and Curiosity and Ingenuity every single day.
Right.
When they're out there. So yeah.
Right.
Now you see them more frequently than we're getting them from the Chinese lander. I'm not saying we're not, but
right.
Yeah. Fair is fair. Yes.
All right. Let's see. Any questions regarding Mars? I see Nick asking what the expected lifespan is for Perseverance.
So it's a little open-ended. The primary science mission is set to last a full Martian year to Earth years. So still 1 year to go on the primary science goal for it. Ingenuity has blown past its, every expectation we've had for it. So at this point, we're literally just using Ingenuity until it won't go anymore. The reason I say it's a little open-ended is because both Perseverance and Curiosity use radioisotopic thermoelectric generators. So they use nuclear power sources, very much like the Voyager spacecraft that are still operating 25-ish and more years after liftoff. It's a little open-ended because that will decay, and the heat that we use to power the systems and keep the vehicles heated and everything will eventually reach a point where we can't do that. The benefit is that we don't have to stop during winter months like we had to do with Spirit and Opportunity, because the power source remains constant. But it's a little bit of a give and take, and you can also start doing things with the rovers like, oh, well, if we don't drive them as much anymore, that's more power that we have for science. So you can sort of, at a certain point, start to do power trades with them.
Yeah.
But to be fair, we're just starting to get there with Curiosity in doing the power trades with it, and not in any alarming degree of time. So Percy still has a long way to go before we would even start to think about that. But because it's nuclear and because there are trade-offs, there's not like and after 10 years, the solar panels won't be enough anymore, because we don't have that with those particular rovers.
Right. Okay. Any other thoughts on Mars before we move on? Because we do have so much. We've got to cover so much. We're going to talk about. We still have to go through everything else. There's lots of rockets and stuff that happened. Space tourism.
Yeah.
Okay. Yeah. So let's.
There's actually one little point.
Okay. Go ahead.
The next year, or I guess this year now, we're going to be seeing the ExoMars launch. from the European Space Agency, the Rosalind Franklin rover. And that's been delayed.
That's the one that missed the window this year, or last year.
It's been delayed a few times because they found an issue with the parachutes. They were doing some last-minute testing of the parachutes to ensure they worked, and they found a major problem with them. So they delayed it to the next launch window, which will be, I believe, around September or October of this year. And Rosalind Franklin will be a medium-sized rover, a scientific mission for the European Space Agency, and it'll be using the ExoMars orbiter, the Trace Gas orbiter, which is already at Mars, to do orbital photography as well as doing communication back to Earth.
And that's a joint prospect between the European Space Agency and Russia, and part of Russia's contribution is the Proton M rocket. So let's hope the gravity sensors are on correctly.
Okay, a little proton jab there. Okay, let's talk about some new rockets this year. We had a couple of new orbital rockets. We had, of course, the Virgin Orbit Launcher 1 was not the first time it launched, but the first time it reached orbit was in 2021, right?
Yes, and this is actually video from not their first orbital attempt, but the first one that they broadcast to us live, and everything. So this is actually the tubular bells from there. But yeah, Virgin Orbit made it to orbit for the first time in 2021 after the first suborbital mission in 2020 had failed back in May, shortly after first stage ignition, and this one went much, much better. And then they had their first operational flight with Tubular Bells Part 1. And we also had another small satellite rocket company, you might say that NASA Spaceflight is quite familiar with, reach orbit for the very first time in 2021. Congratulations to Astra. This was video from our joint live stream that we did with them for the launch of the LV0007 vehicle, which was the first of the Astra missions to successfully reach orbit after one in 2020 successfully reached orbital velocity, but the trajectory was not quite right, so that its perigee was a bit too low, even though it achieved the proper velocity. But this one achieved the proper velocity and did the simulated deploy of its payload, even though it did not deploy anything on this particular mission.
That was super exciting that finally happened for him.
It was. And but then we also had two rockets enter the arena on their very first liftoffs as well. Ian, do you want to talk about Firefly and Nuri here?
Yeah, so with Firefly, their Firefly Alpha rocket, that's supposed to be a bit on the higher end of the small sat launch rocket, a little under a ton to orbit per launch. So they did their first attempted launch out of Vandenberg here. We can see a video from Jack Beyer from NASA Spaceflight, who was on scene there. And they had a successful liftoff, but shortly after liftoff, they actually lost one of the 4 Reaver engines on the first stage. And because of the way that the engines are sort of hooked up to